So, welcome everybody to the last event of the day. It's been a long day. I think it was a really great day. If you've been here for the panel, who enjoyed the panel? Well, yeah, like we never had a panel like this. If that's, that was Vitaly's idea, and one of the reasons he proposed this idea is that I added too many people to the panel. So he wanted to have about 4 people on the panel, but we ended up having 6 people on the panel. And he said the only way we can do this is by debating one half against the other. So we had this amazing debate, right? Like function program is good for machine learning. So that's really awesome. So that's an innovation in the Fireside chat innovation. Yesterday we had Fireside chat with Ben Hinman, Ian Downs, and I think we really learned a lot about messes and mesosphere and why we all hate containers. So that was really interesting. So today we're talking about storage, and so we have a similar format. We have Evan Weaver, who was the first lead on storage team, right?
Leader's a strong word for what was happening at the time, but
right, from the inception. And Boaz is the current leader of the storage team. So I think I'll let you guys introduce yourselves and tell us basically what you were doing then and what you're doing now. And maybe Boaz, for you, like what you were doing at the beginning when you joined Twitter and what you're doing now, right? And how it all relates to storage.
Yeah, I'm Evan Weaver. I was employee 15 at Twitter and started in 2008, stayed about 4 years. And initially, it's just me and a guy named Roby Pointer working on scaling MySQL. And that grew and grew into what we called the infrastructure team. And eventually, there were multiple teams, including the storage team, which Boaz is the cultural inheritor of. And we built all the distributed operational storage. So that was tweets, timelines, user storage, social graph, image storage, the cache, some other storage. Those were effectively point solutions. And we were frustrated that we never had the business investment horizon to create a truly reusable internal data platform for Twitter or via open source for everyone. So when we left, and a number of the people who were on my team eventually came with us, we started a company called Fauna, which is making FaunaDB, which effectively is that platform, but from a vendor perspective. And I will let you tell about what happened after that within Twitter.
My name is Boaz Avital. I joined Twitter, I want to say 2 months, 3 months after you left. And onto the storage team. At the time, we were working night and day, making sure that the databases stayed up. The Gizzard databases that you guys built and the Cassandra databases serving data, different kinds of data that we created ad hoc. And over time, the company continued to grow, the number of users continued to grow. The number of things that we were trying to build at Twitter continued to grow and multiply, and the team that handles storage can't grow proportionally with the number of things that the company is doing. So eventually, we decided to build our own database with a lot of things in mind that were important to Twitter at the time. Given our constraints, and that's things like a multi-tenant database that has self-service as a first-class consideration, operations as a first-class consideration, so that this thing can scale, truly scale in practice, not just in theory, to the scale that Twitter needs, both in terms of requests and storage size, but also in terms of the number of people using it and the number of people operating it. And that database is called Manhattan. Today, we started building it 6 months, less than a year after I joined, 6 years ago. And today, it's the canonical store for tweets, for DMs, for users, advertising data, and a whole long tail of things that I don't even know about because it's self-service and nobody has to ask me.
So, the immediate question, right, as an outsider, so we're in the meetups talking about open source. about people picking open source projects and using them, right? And so one of the examples, Smegstack, and C is Cassandra. So why is it not good enough for you guys, right? So like, why couldn't you pick one? And so if you look at EdgeBase, right? So Facebook picked EdgeBase, made huge contributions, but it's kind of all out there. So I don't know how much. So they did Hydra, they did like some internal additions, right? So you seem to follow kind of the opposite model. So Fauna built its own database which you're going to manage. And Twitter has essentially the same internal managed database. So I'd like to kind of understand better. So are they kind of descendants of Cassandra, right? So you talked about early days of Cassandra. And how are they different from Cassandra? And how are they different from each other? And why do you have to kind of reinvent the database for the specific needs you have at Twitter or for the customers?
I mean, we were involved in the early Cassandra community. And in a way, you could conceptualize Fauna as like a Cassandra 2.0, but I think that's doing it a disservice because a lot of the things that we wanted Cassandra to be at the time turned out in practice to not be the right set of trade-offs, especially in transactional operational data. So a lot of the things that Boaz mentioned as being important to Twitter later at a later stage of maturity are the same capability that we also discovered both in our experience at Twitter and then also in the marketplace as an enterprise software vendor, like multi-tenancy, QoS management, a better security model, strong consistency, global replication, and data sovereignty control, a whole host of, especially for a startup as chaotic as Twitter in the early days, things we couldn't even dream about solving before we solved the immediate scale problem and the keeping the site running problem. So I think in a way, it's that experience, in my view, which is translated into both systems, not the code itself, but you're welcome to correct.
Sure. I mean, we were really heavily into Cassandra. It wasn't the storage system that was storing kind of what you would think of as the main Twitter data, the social graph and the tweets and all that, but it was a great system and it was the easiest way for us to store a lot of new use cases and to scale a lot of use cases that at the time there were no other systems, Cassandra installations that scaled to the level that we did, including like millions of writes second for our observability stack. But the changes, ultimately, it's a very hard decision. And we had Cassandra committers and people on the Cassandra PMC, and we had to make the decision about whether we wanted to contribute back and to fork or to write something from scratch. And we're working on in this company under the kind of the reality of all of the constraints that we have to work under in order to deliver value to Twitter and make things right as fast as possible. And the number of things that we identified at the time as issues with Cassandra that we wanted to change, to simplify. We had different goals in terms of scale versus features. We had different goals in terms of portability. We have this wonderful infrastructure that we can leverage as being part of a large company. So there were a whole host of things that we wanted to replace in terms of internals that didn't match the roadmap of the community at the time, and we didn't want to be disruptive to the community either. So ultimately, that caused us to decide to build our own thing because we knew what we wanted and how to do that quickly.
So I want to still stay with this topic for a moment, right? So we talk about the Smegstack. It's kind of one of the terms, generic terms, right? So if you look at the C doesn't mean Cassandra. It means Couchbase. It's basically some persistence. It looks like it's the weakest letter. So K is the strongest because Kafka stays, right? Like when we talk about architecture, Kafka stays because everybody's using Kafka. It's very hard to find a company which needs a message bus which is not using Kafka, right? So in Amazon you have Kinesis, right? But basically it's still K, right? So somehow you have very solid K, and S stands for Spark. It's really hard to compete with Spark, right? You need ETL, you use Spark. right? Mesospheres for operations, again, we have Uber, Netflix, Apple, pick Mesos, without Mesosphere, right? So Arc is an API, again, it's open source. What is it about the databases which makes them, first of all, so hard, right? And so organizations tend to, so you mentioned some of this, right? But I'm curious, is this like a law of the land that big companies have so bespoke needs, right? They're not reinventing Spark. They invented Scalding, which they kind of, sent to the world. But, companies are not reinventing message buses all the time. So LinkedIn invented one, and now people are just picking it up. So is it something specific because data is at the heart of the company? Data is very different. What makes this, piece so important that people reinvent their own?
I mean, we did write several message buses at Twitter, to be fair.
And other companies have built a lot of their message buses.
I think, I'm sure Kafka is used now along with whatever Kestrel's like grandchildren are. But I think ultimately data, especially synchronous transactional data, is simply the hardest problem to solve. And that means it takes the longest, but at the same time, there's the most opportunity to make an improvement on the status quo. When we started at Twitter, it was MySQL vertically scaled and not very high in terms of vertical reach. There have been many iterations since then that succeeded and many that failed to get to the point where you have a system like Manhattan. And I'm sure you can tell there's still a long way to go in terms of capability and business value that can be delivered there. And I think fundamentally, it's just easier not to try in a way and stick with the devil you know, either for SQL or now some of these NoSQL stores like Cassandra are incumbents, but their fitness for purpose continues to get worse. And they continue to fail to keep up with the way people build modern applications. And I think if you can actually build a genuinely modernized system the way Confluent and Kafka did for message buses, there's huge value there. So that motivates people to keep at it.
I mean, especially early on, years ago, if you look at what a database is, it's not just one thing that anyone's trying to get out of it. Obviously, everyone would love like a MySQL that scales forever, and you never have to think about it. Then we wouldn't be having this discussion. But the trade-off space of what are all the things that you can build, and if you choose that one thing is important to you, you have to give up something else, is huge. And there's points on every point of that scale. And any database you choose is going to make different trade-offs. And no two databases think about the data model the same way, or how requests happen the same way, or how replication happens quite the same way. And those all have consequences. So eventually you get into a position where what is the main way that your company operates, and how do you leverage the database to be the most useful for that? And when you, I guess it was in the earlier web days when there were only a few companies, and Twitter was one of them, where we were at this kind of enormous scale, you run into problems that people just didn't run into.
Thank you. So again, I see some similarities, right? So Fauna is the managed database for end users for multiple companies, and Manhattan is essentially managed database for internal Twitter. So can you talk a little bit about the managing aspect? So how does this happen? So I'm a new company, I want to onboard on Fauna. I'm a new team at Twitter. Can you describe what needs to happen for this?
So Fauna is a monolith. Operationally, you run one jar on each machine in each data center in your cluster, VM, instance, container, whatever you have. But the user experience, even whether you're running on premises or in our cloud, is essentially a SaaS experience. You query an API to create a new database. There's no provision capacity. it gets a priority assigned potentially by you or potentially by an operator on the other side of the wall, so to speak, that limits the damage you can inflict on the machine resources with your workload. But it's like an opaque, data fabric or utility, essentially. That's what we deeply and painfully missed when we were at Twitter. And that's what Manhattan, in a lot of ways, has solved. I think the biggest difference between the two systems is because Fauna was built to be packaged and shipped to an operator or an enterprise who we as the vendor don't control. It's all in one. Whereas Manhattan is, in my understanding, designed around the service architecture that Twitter uses for everything. And you can talk more about maybe the trade-offs involved in doing that.
Sure. And yeah, I mean, when you build something into the infrastructure like that, you make a lot of choices that are simple for you, but make it hard to make it portable later if we want to open source it and stuff like that. And that's unfortunate, but it does make it gives you a dependency on other people, on other teams as well, and other things that the company have to be running for the database to run, which when you're at the bottom of the stack, like makes you a little bit uncomfortable sometimes. But ultimately, it's a huge boon to the speed of development and the things that you can rely on. For us, to answer your question, it's the thinking was if you were developing software outside of Twitter, you'd be putting it in AWS or in a cloud, and you'd be able to use a managed service, a database service, and just ask for capacity and get it. And it seemed silly that it was harder to set up storage inside of Twitter, which is this walled garden where we all trust each other and like it's there's a lot less controls than it would be getting it outside of it. And so we built it specifically for that need to lower the amount of time that it takes for someone to get storage going so that they can think about how to actually build their services instead of thinking about provisioning databases. That was the goal, and like there's a lot of things around it that we had to build, and metadata distribution and APIs and web UIs and all this stuff that you don't normally work on if you're working on a database team at a company. But getting that breadth, like thinking about this database as a product, truly, like we're a startup inside of Twitter instead of just building a technology and managing that product and running it ourselves. Really changes the way that you think about building the software, and you build it in a better, more robust, safer way at the end of the day.
Yeah, I agree with that. Like one of the things that was a big difference for me going to Fauna from Twitter was we had a marketing budget. So, we could spend time telling people how and why to use our software. And internally at Twitter, when there's always the next fire to fight, and we'd be like, here's some code, if you have to scale data, like our code is there, or you can put it in the existing system, but don't break it because there's no isolation. So don't put too much, or there's this special pool to play in for all the bad actors, and like you said, very little leverage, especially for the product organization, and ultimately extremely efficient, but also extremely brittle systems. And both platforms are a response to that.
One thing that I envy, though, is that when we get customers, we're not allowed to charge them and turn a profit, and so they're not thinking about it that way. We have to break even on our costs, unfortunately.
Zahir, can you talk a little bit about running, operational component, right? So do you run Manhattan on Mesos?
We don't run Manhattan on Mesos. We run it on physical machines.
Okay, so basically, both systems have to assume that the cluster is just a set of machines. Like you do your own cluster management, your own resource management.
Yeah, I mean, traditionally, even in non-distributed databases, you treat the operating system as no more than a collection of device drivers. Like you want to own everything end to end because tight coupling is mandatory for performance. And Fauna is built completely on the JVM. It's implemented in Scala. It runs on a standard JVM, which makes it easy to deploy. And what else happens outside of that world is not specifically our concern. Our goal is ubiquity, and then relying on the JVM to deliver that maximized control over the machine resources that are there. Because a lot of the stuff you have to do, and that we had to do in these systems at Twitter for performance reasons, required breaking down interfaces between systems, whether that was libraries or services or processes on the same machine. If you can't share information, you can't make better performance decisions. So the more that you own for a database, the faster and also more predictable performance you can have, which is critical for customer-facing workloads. And that story was the same for System R, and it's the same for us today.
So how do you think about performance in Fauna?
So our focus is on predictable performance first, and then throughput second. So it's paramount to be predictable. After that, you want to be reasonably low latency, and after that, you want to be as high throughput as you can within those constraints. It's worse to have a system with twice the throughput but twice the variance, because applications get built to the implied performance profile that the system delivers, not to whatever your docs say it may do in a worst case scenario. So it's really about, if you want the customer, whether that's internal or out, to have a great experience, you need to make sure you don't lead them astray in either direction in terms of the performance profile. And that also means performance under faults, which is the traditional downfall of many distributed data systems, where it works great in a lab or in a vacuum, but under real-world varying workloads and with faulty hardware, especially hardware in the cloud, which is even worse than on-premise hardware, even to this day. It's great you were up all day, but that 1 minute where latency went up 100-fold destroyed any perceived trust any of your customers have in the system.
I mean, there was an explicit design goal in Manhattan from the beginning, optimizing for worst case, not average case performance. And over time, I think as Twitter's architecture matured, what used to be a short blip in latency for other systems causing a lot of problems up and down the stack stopped being the case, which was a great benefit and one of the reasons why the fail whale kind of went away. And so I totally agree with a lot of what you're thinking, but also things that we continuously run into and that I can't imagine having somebody else running my database on their machines is constantly we're having kernel level interaction issues, other machine level configuration issues. Things aren't set up correctly on their box, and it's causing pathological performance for whatever reason. And we've had to investigate that ourselves and become, with the help of all the great OS and VM teams at Twitter, become experts in how to run these systems in reality. And just handing it to someone else, I can't imagine oh, you guys are running this bad version of this kernel with this bad version of this OS with this thing that we try to do. And so, yeah, your performance is crushed. I'm sorry. Have you run into anything like that?
Yeah, we have. And that's why you have a relationship with your vendor. If you want, beyond adequate performance under the worst case operational topology and you're running it on premises, someone has to investigate end to end to understand that there aren't artificial bottlenecks induced by configuration or dependencies. Because there's still chips and an operating system and other stuff going on. We're not shipping you an embedded appliance. At the same time, though, that's one of the biggest benefits of us running a first-party cloud and deploying to that cloud. And our cloud is layered, it's software defined, it's layered over AWS as well as GCP, and one of these days Azure as well, we experience the diversity of deployment environments. We can do that management and then offer to you, the cloud customer, consuming Fauna over an API that perfectly tuned and safer deployment scenario. But if you're the enterprise and you have compliance requirements, there's no way we can possibly address all of those in a managed service. So.
Thank you. So it sounds like there is a lot of similarities, right? Like it's kind of another similarity. So I noticed on the Twitter panel, you were the only one arguing for the closed source solution, right? And I think, right? And Manhattan is not yet open source, right? We had this meetup here, Twitter, maybe a couple years ago, right? And I was immediately asking, when is this stuff going to be open sourced? And I think the answer is very, very cautious, right? And so you said, like, you guys worked on it for 6 years. So do you plan to open source Manhattan at any point? And basically, what are you thinking, guys, about open sourcing such a complex thing as a database?
Sure. I mean, it's not off the table. I would love to build a community around Manhattan, and I see value there. When you're thinking about this complex system that's so tightly tied into our infrastructure and where so much of the value comes from the ecosystem that we've built around it, the good tooling and the good agents that manage things and the APIs that run alongside it and stuff like that, that it just has to be done mindfully, and that's work like any other work. And we're here working to make Twitter better, primarily, and so that's work that has to be prioritized against that.
Yeah, I mean, our experience working on some of the very early Twitter open source was the calculus dramatically changed even before, we were 600 people, even when we were 200 people, where in particular for the thorniest problems, which were often the data scalability problems, the help you got from the community started to fall below the effort it took to maintain that community. And part of it is because of this need for specialization in your own system versus trying to address more general concerns for people who are solving much, in particular, problems at much different levels of scale. And I even experienced this in like much less significant open source projects like the Memcache driver I worked on a lot, where it was in the critical path of Twitter's Rails app for years and years. And any like a single-digit percentage degradation in performance was a crisis. But I'd get all these patches, which would be like, let's add a feature. It makes performance 10% worse. That's not a big deal. It's Ruby. I'm like, it's a big deal. And it's just hard to balance all those competing concerns. And at the same time, I think, in particular, like things like containers and other middleware, which derive a lot of their value from conforming to standard interfaces. In practice for databases, that's never really been the case. Like even SQL isn't truly a replaceable standard. Like there are edge cases in functionality. There are all kinds of edge cases in performance. The operational interface is completely uncontrolled. Like there's no world in which dropping something new in gets you a benefit, and that makes it very hard, in particular, to get a lot of people to collaborate, each of whom are narrowly focused on solving only their most acute problem.
You work with a lot more other companies than I do, obviously, but my perception has been that definitely early on, very few startups and small companies had what we would consider like real scale. But it seems like that's changing, and like a lot more small companies are finding sources of data wherever they're coming from in the millions of requests per second range with varying levels of latency requirements. Do you also see like more companies are using that big scale?
Yes, but at the same time, Moore's law has, for better or worse, continued to keep up. And the level of vertical scale you can get in the cloud on demand from vertically scaled legacy solutions has essentially kept up with the pace of data growth. So I don't know that the equation has changed that much because you still have very few companies which are forced the way Twitter was to invest in scalability for its own sake. What you do have are companies that suffer because of the weight of integrating all the different data solutions they're trying to use get captive by overly narrow, either NoSQL or legacy scaled SQL solutions, and then get to a point where their scale is okay, but their productivity has ground to a halt because they can't both expand and isolate the different workloads they're trying to run against the same data. And we had that problem at Twitter, and it's still happening today. So I think like scale itself arguably never was the most acute general issue, but productivity at scale absolutely was and continues to be so.
Thank you. So I think we're coming to the end of the half hour which we had, right? So I kind of want to end with the question: what is the hardest challenge for you right now, right? So for Fauna and for Manhattan, what keeps you up at night? And what do you think will happen when you will overcome this challenge?
I think we have a really interesting challenge at Twitter building our database because as a company we kind of have grown to rely on it. There's been times when I've actually told someone we offer MySQL, for people to use for their data like anywhere else should, and I've told someone like, your data model fits better MySQL, your requirements fit better MySQL, you should probably use that. And they say, yeah, but Manhattan is so easy to use and I'm already used to it, and this and that all fit the NoSQL model. So people try to use this database for all kinds of different things. And like Evan said, the more you kind of understand the use case, the more you can fit your database to it. And so in addition to making all of the core things that we do better, we have a really interesting challenge to work with all the different teams that use Manhattan and Twitter and build new features and new ways of storing and accessing and querying data so that it continues to grow and be useful for everyone, regardless of the kind of ways they need it.
In a way, I have the same answer. I mean, technical problems can
Glad I went first.
Technical problems can be solved, but changing behavior is the hardest thing. And in particular, in databases and transactional operational databases, like the risk of using something new, whether that's something that's not Manhattan in Twitter or whether it's Fauna compared to whatever the incumbent thing may be, is rightfully perceived to be extreme. And both showing people the value they can get from working with a new paradigm and a more trustworthy piece of infrastructure just takes a lot of work. And it's people work, it's marketing work, it's sales work, it's documentation and support work, as well as actually delivering on the core premise of the technology itself. But I think that's always been a bigger challenge for anyone in the data space than making like an algorithmic improvement or something like that. Fauna doesn't go down, so I'm not being woken up by pages or anything. So at Twitter, that was my main thing that literally kept me up at night, but that's no longer the problem for us.
It's a lot better.
I believe you.
Great. Well, thanks, guys. I think we wish the most of success to Fauna as a company, a new company in the marketplace. And congrats to fundraise and be present here. We always support Scala companies and other companies. And Boaz, most of luck to you at storage at Twitter. We hope at some point see more about Manhattan. It's a very interesting topic, right? So we were happy to have a meetup on this and looking forward to learn more.
Thank you very much.
Thanks, guys. Let's give a round of applause to our.
Thank you.
Thank you very much. It's been a long day. We have about 15 minutes. I don't know if anything is left there, but enjoy yourselves, and I see you guys bright and early tomorrow.